My computer will be tied up, so someone else has to do it.
Yeah. So let's start. Dom, I'm gonna have to get you to mute. Sorry, it's.
There's no link to them in the Slack page for meetings, but there is. I am looking at it.
Mike, it's in the general channel.
Oh, it's not in the meetings one?
No.
Oh, okay. Okay.
Cool. So let's maybe start. Franklin, would you mind introducing yourself? Because I think there's probably a few people here who don't know you.
Yeah, sure. So I'm Franklin. I work with Rowan at Sequent. I guess I was Adam's PhD student for a bit before. I don't know if people know Adam, Rowan's advisor, I guess. Yeah, so I was his PhD student in geophysics for a bit. So I have geophysics background, but now I do mostly coding at Sequent, working on the Python side of things. And my title is integration lead. So I do like sort of partner integration stuff and like API clients and getting people external to the company using our stuff. And I guess I wrote properties, which a lot of SimPEG is now kind of built on. So that's my biggest SimPEG connection. I don't know, is that satisfactory?
That's great. More than satisfactory.
Wonderful.
Excellent. Well, so the way we structure these meetings, for those of you who are new, we start with just like quick updates. So we'll get sort of a 60-second max update from people who have stuff that they want to talk about. And then we'll move into the longer discussion. So I can maybe give the first point, and Dom, feel free to jump in here too, because you're involved in this. This week, we started a new GitHub organization called GeoSci Data. I think it's GeoSci or GeoSci.xyz Data. I need to double check. I think it's GeoSci.xyz Data. And so this can be a GitHub organization where we can post data. So for example, right now, Mount Isa, the data are there in a single repository. It would be nice down the road, we can maybe create like a little bit of a template, just like with a link and showing some licensing suggestions and things like that, so that we embed some best practices from the ground up. Yeah, so it's meant to be a place where people can put small-ish data sets, so it shouldn't be enormous, but something that can easily be hosted on GitHub is welcome to go there. I think right now only Dom and I have admin access. So just ping either of us. We can add anybody. At some point this weekend or something like that, we can try and add all the SimPEG group. But if you need something more immediately, just ping one of us.
Lindsay, why didn't we use the GeoSci data? Because there is already a repo, right? For I was wondering. You see my screen? Oh,
so I think in terms of reuse, it'll be easier if each data set is its own repository. Because in that case, each data set can be licensed individually. So Mount Isa, like we don't own those data, so we need to honor whatever licensing restrictions, I guess Peregrine or whoever owns them wants on them. So that'll give us, like, if each data set is under its own control, then licensing is much more clear. So we can maybe move, like, either treat the GeoSci/data as just like a list, or it could eventually be the website that points to all the different data sets that are in the GeoSci.data.org. Does that make sense, Tom?
Yeah. I mean, yeah, you're the boss.
I don't know about that, but cool. Do you, Dom, want to jump in and give a quick update on the notebook for inversion training?
Yes. So Doug asked me to start putting together a potential field mag example for training. And so I thought that we'd be plugging in with what Peter did for the viewing. Let me move this here. So that's pretty cool because we can use the interaction to be able to do the slicer at the same time as using the IPython widgets. So both are connected at the same time. That was pretty cool. So we can do basically forward simulation of the block at the same time as the data, right? So we change the model and then see the magnetic response at the same time. And then from there, we'll just be able to run the inversions and then show the result. So that's kind of the idea. Be able to change the noise level on it at the same time and then just re-invert right away, So don't have to like rerun the multiple notebooks. Just change the model, change the noise, and just rerun the inversion. That's the idea.
Very cool. Dom, it looks like you're still on tap. You and John, do you want to talk about the mag radiometry?
Yeah, well, so congrats to John. John finally managed to get the integral running. So now we have gravity geometry. I'm not going to show you anything. It's the same thing as last week. But I started a pull request. Now the question is, there is the whole Dask thing that is already started. Did we want to do 2 PRs, or because it's going to be a lot of work if I do 1 PR for to bring the gray geometry and then another PR to do Dask, or we could do it all at once if you guys are okay with that.
Have you started a pull request, like a work in progress pull request?
Good question, and there's a branch definitely, but let me check.
Because that would really help, like, sort out that question.
I guess no, they're just branches.
It's shift tools that you. Is that the repository?
Oh yeah, sorry, wrong repo. Oops. SimPEG. No, hasn't been started yet. I'll figure it out. We can talk about it next week. Yeah. That's it for me.
Cool. Thanks, John. Kevin, you want to jump in and tell us a bit about SAGI?
Yeah. Everyone. Yeah, for those who don't know me, I'm a research assistant at UBC for Quintag. Yeah, I did a short presentation last week where I was at the Near Surface Geophysics Conference, SAGI, and it was in Portland. Actually, it was just a talk during the student evening, so rather short. Yeah, but I got some good contacts afterwards. There's some people who had some recommendations for borehole instruments. And I think given our budget and scope, it's probably not so applicable, but it's nice to have contacts. And I also did have the opportunity to talk for a good time with the program officer with Geoscientists Without Borders, the foundation with whom we're trying to apply for funding. And this is for a project to do hydrogeophysics in Myanmar, basically, to alleviate droughts. So I think we have a supporter in the organization now, and that makes me really happy. Yeah, and I also spoke to Paul Bowman, and he's really done a ton of really cool projects in the humanitarian space for water supply before in the Kakuma refugee camp, and I think it's Kenya and Uganda and Cox's Bazar in Bangladesh. So he had lots of insights as well. Yeah, I think that's the essence of my time there.
Very cool. Thanks, Kevin.
Thank you.
Sarah. Sarah at UBC, I believe, is up. Kevin, I'm just going to get you to mute if you don't mind. Okay. And then UBC, I think, is Sarah around today? Dom, you're
Go for it.
Okay, I just said, I think the sentence in the report says it all, actually, you know. I can't see you anymore. Yeah.
For those of you that are not in the notes right now, Sarah's asking how do we get a hold of the SimPEG stickers? And so Rowan, I think we can connect on that.
Can you show my computer? I wanna. Do you see it?
Yes, absolutely. There's a
I
space.
want to populate with a. Anyway, it was not important, so it was really not bad.
I'd say it's pretty important.
We should get our socks.
So you can be in charge of stocks.
That's all I want.
Excellent. Sagi, would you like to jump in and tell us a bit about your power line work?
Yeah, I kind of want to show quickly. Actually, I forgot how to share my screen. So I was actually using Octree code, and I was using DOM's mesh builder. I had to change a couple of things, but this is the power line that I have built up. So it's actually pretty small mesh, like a couple of centimeter mesh for the power line discretization. But the full mesh is pretty large. So I think I ended up using about 1 million cell. But I can actually do this, which I thought pretty cool. And like at the end of the day, what you get is something like this. So this is the simulated data. And that's a field data. So, well, it's not exactly the same, but it's pretty similar. Meaning, like we can actually model the power line effects from the airborne data, which is, I thought, pretty cool. And yeah, without the Octree code, it'll be much hard. It would have been much hard. So yeah, I really appreciate all the people who developed this. Pardon me?
What did you have to change? What did you add?
I think I had to change a couple of, not really that many things, but you got the limitation of the Octree levels. I think, especially for the point code, the point data, like you only got 3, I guess.
It's a list, so you could have added as many as you want.
No, but I think if you look at your code, there's an assumption you made, so I had to change that part.
Okay. Well,
yeah. So it was. Yeah, I just had to change that to just a little bit of generalization. I didn't change that many things.
Sweet. So you'll push it back, right?
I just generate a branch from your repo, and I pushed. So we can make a pull request to your local branch, I guess.
Perfect.
Anyway, that's it.
Thanks, Sagi. That's super cool. So just a quick update from me. I won't necessarily show this right now, but following up from last week with Andrea's question about running anisotropic simulations with SimPEG, I went through and just created a simple example that compares a time domain simulation run in 3D with SimPEG with an EM-PyMod simulation that runs 1D. And overall, they agree quite well, which is exciting. And right now, it's with a very coarse discretization, so it runs quite quickly. But it's encouraging to see that, yeah, they're producing similar results. So check that out if you're interested in anisotropy, and feel free to fire questions along. Dom, sorry, I'm just going to mute you again. And then the other item, I just wanted to thank Kaylin for all of your work on upgrading examples and fixing stuff as you're reading through it. That is enormously helpful.
There'll be more to come eventually.
Excellent. Is there anything anyone else wants to provide a quick update on? No? All right. Well, then I can turn the floor over to Rowan and Franklin.
Hey, cool. Been a while since I actually joined a meeting, and I think maybe this is Franklin's first time or second time.
I did both of you whenever property comes up.
So, yeah, fair enough. Yeah, I wanted to maybe just give like a quick overview of some of the work that we're doing at Sequent with the open mining format with the Global Mining Standards Group that might be of interest to some people here. Who's actually heard of OMF or Global Mining Standards Group at all? Cool. Cool. So I guess from oh man, the screen sharing has changed. There it is. Sorry. Can you guys see my screen?
Yep.
Cool. So this, the Global Mining Standards Group is sort of the industry standardizations body for dealing with mining operations. So they do everything from sort of the exploration side right down to sort of operations. So that's like streaming data from people and machines going around a mine site. And so where we've been involved with sort of Sequent and Leapfrog, which is a geologic modeling software, is on the data exchange for mine data, and sort of that covers exploration to everything through to production, but like less so on the operations space. So streaming data isn't really in this piece. So this the idea here is to like build sort of this open source file interchange format. So a lot of the software packages in the industry don't communicate well in terms of linking up workflows between two sort of proprietary formats. And so that's something where the GMG is trying to step in, propose an open mining format so that we can actually do that. Franklin, is there anything you want to add to that?
Not really. I mean, I think that like, I don't know, one like aspect of our approach for the whole time is more like designing an API rather than an actual file format, like an API and how objects are communicated. And I feel like that's been kind of an important shift. That and the open nature of it has been kind of an important shift in the industry.
Yeah, no, I think it's like totally cool to see like these very heavily proprietary software companies and mining companies. Sort of both Franklin and I have been hammering through on the open side of it so that we can actually get to open standards as well as open development of this file format. So like getting all of it onto GitHub, having contributor guidelines, code of contacts, all of that sort of stuff that you'd expect from an open source project. So that's been pretty cool.
I have a question. Is this also related to what EarthCube did a few years ago? They also developed this open data standards for the geosciences.
So no, there's probably like a ton of different like open standards, which makes them not so standard. But this one's specifically focused around the mining data, which has some more specific needs, especially around sort of storing, they call them block models, which are like equivalent to our tensor meshes or regular meshes. So that's sort of where they're coming at it, but we're also trying to work with other standards bodies like the Open Geospatial Consortium in terms of just some level of interoperability, even if it's at like naming conventions at this stage.
Okay.
Yeah, I don't know. Franklin, do you have that pull request open? Just in terms of like talking about how it relates to discretize?
Yeah. Yeah, I'll share my screen and then let you talk more.
Instead of me finding it.
Yeah, maybe I just have to find the share screen. Oh my god.
It's on the left. They changed.
Okay.
Clearly don't use Hangouts enough.
Super. Okay. So let's see. I don't know. There's this. Do you want this or do you want the pull up?
Yeah. So this is sort of like the overall formats that are going to be introduced of sort of specific relevance to the discretize world, or the regular tensor and octree pieces. So it like, I'm not sure how how fast this is going to progress, but it could be a way to just an output format for discretize to actually write to the OMF format so that you can save data as well as load it up in things like Leapfrog or Geovia or any of the other sort of mining software packages out there. And then there's been a couple other, like Bain Sullivan wrote OMF VTK. So there's been a little bit of open source work done in sort of the visualization space as well. Cool. Yeah. Franklin, you're on mute. Yeah, I don't know. I don't really have anything else to say on that.
Yeah.
Does anyone have any questions on the OMF piece, or just what we're trying to do there?
So, Rowan, so is it like so at the moment is particularly for like a kind of voxel discretization, like a tensor mesh, and have a 3D model? Like, is that the focus at the moment?
So that's the focus of the version 2 effort primarily. There's already meshes in there.
Right.
And sorry, there's like surfaces in there that can be sort of triangles and vertices, so that you can like store like geologic bodies or faults or something, and some drill hole like data that are sort of stored as lines. And so you could also have sort of GIS topography lines on there, and also point set data. And so sort of 0D, 1D with the lines, 2D with the surfaces, and 3D with the voxels. And the voxels is the piece that's sort of getting progressed as sort of a high priority piece in the mining industry.
Right. In terms of well data, like a drill hole data, let's say it got a lot of lithology or different mining units, and how do you kind of, do you have such certain format that we can store that?
It's yes. It's probably not the most useful. I could bring up the docs. I'm just sharing again. Can you see my screen?
I was actually just watching Franklin's screen, but
am
I supposed to watch yours?
Stop sharing it.
So this is like point set data, line set data, which can be sort of the GIS lines, but I'll show you maybe a different version of that in a little bit. And then the surface data, which is just the triangulated ones. And so the line set one is what is currently being used for things like drill holes, and all it is this sort of vertices and segments definition. So you have your desurveyed drill hole, borehole in XYZ space, and then you define the segments to actually fill that line set in, and then you can attach data to that. And you basically put it at the location of vertices or at the location of segments.
Right. I see. Okay. I just got a quick question. Okay, even just step back. So there are like tons of formats, right? So even for, let's say, the well data, there are a lot of like formats. And what's your vision to handle, like somehow you need to transfer that into this format, right? What's what are the vision here? How are you seeing this problem to work it out?
So I guess a lot of those, again, this like where this is sort of being positioned is on a data transfer level between primarily the mining software packages in the industry today, and so that's the problem that it's trying to solve. I think where it gets a little bit more interesting is on the volume, like block model storage. So, and then in these other standards, in terms of like last data or some other drill hole database, we would eventually go through and add that sort of extra layer that hopefully coincides with or is interoperable with those standards.
Okay.
So it's allowing the mining industry its own space to play a little bit, and then sort of standardizing over time. That's like a bit of the vision. What there really isn't, especially on the subblock model, anything out there, and that's the primary pain that the mining industry is feeling at the moment.
Yeah. Well, not just mining industry, I guess. Like a lot of.
Yeah.
Okay. Good.
Are there any thoughts, like in developing all of this, that we might consider when sort of rewriting the data class, or like what that should look like? Because that, in some senses, is like a point set. Maybe it's a more complicated point set because it's like a time series at each point. But is that sort of in scope? And then also, even if it isn't, what kind of things do you think like we should have in mind in developing that?
So it's not really like specifically in scope. It is like in the more general sense, in that you can have points with arbitrary metadata associated with them. So it could be a output format from SimPEG, and like the container that it's writing to is not going to be overly glorified. So it could be better to maybe write to HDF5 or something like that from the SimPEG side, but having that standardized thought about how, and the primary drivers between the design of this are Franklin and myself. So I think like we have put a lot of thought into how to sort of like bind data to these things in the metadata space as well. So there could be like ideas that you pull from there. That makes sense.
Yeah, I think so. I think like perhaps as we step this out, this would be a good issue to loop you both in on, just get your insights there.
Yeah. Cool. Any other questions on OMF related things? Cool. Maybe I'll kick it over to Franklin if he's not frozen. Oh, okay, cool. Franklin, do you want to? So one of the things that I guess Sequent's been working on over the past couple of years, we worked on Steno 3D a little bit, and then we pivoted to like better integrate that with our Leapfrog modeling desktop products. And so we're coming back into sort of the scientific community a little bit over the past couple of weeks in terms of opening up some of our APIs in the way that we did for Steno 3D. And so it's beginning again to be of interest, hopefully, to sort of the wider scientific community. So in terms of having visualization, so maybe I'll hand it over to Franklin to give a bit of a demo.
Yeah, sure. So I mean, View, LFView, the thing that we made that I'm going to be talking about is just basically like a online viewer for 3D data where you can upload your 3D models and then share them with whoever just through an email address. Then people can open up their browser and take a look at it. And yeah, as Rowan was saying, it's been kind of integrated pretty tightly with our desktop products and hasn't had an open like Python client until now, but now we do. So here, let me share my screen and I can show this. Cool. So I actually pulled a couple geophysics examples because those seemed relevant. And actually these are from work that Paul did, and this is work that I did too in Gulu, which is in Uganda. And so this is kind of showing view with some geophysics cross sections. This is just DC resistivity. And yeah, so the objects that you can display in here are pretty much the same as what Rowan just showed through the ONF docs. So we have like triangulated surfaces, lines basically, and points. And you can also have also have another example here. We also have volumes, so this could be useful for like modeling results as well, in addition to data. Yep. And so these are just a couple other examples of projects that Paul did. These are from his more recent Bangladesh work. And yeah, again, these are just like resistivity lines with wells and maps on the top, so you can kind of see where they are. So yeah, I don't know. I feel like this is actually a pretty useful way to share data, and I feel like it's relevant to SimPEG because this is, I don't know, it's all 3D data.
Yes, can you explain the slides a little bit?
Yeah, for sure. Sorry. So.
Sorry, Franklin, I just wanted to ask you. Paul, you mean Paul Bowman?
Yeah.
Oh, okay. Wow,
that's right.
That's great.
Yeah, I worked with him for a couple of years when I was a student at UFC and did a bunch of field work with him. So.
Okay, sure.
Yeah.
Okay, no, I really am inspired by his work.
Yeah, because it takes the spotlight off.
Cool. So yeah, so sort of what. Sorry?
Where are you, Kevin? This is nuts.
Where am I?
No, I'm in a Starbucks. Yeah, there's some music in the background.
Yeah. Cool. Yeah, great. So so over here, this is like the elements panel. So elements is what we actually call these different objects. So like the topography is an element. And the different ERT lines are each an element. So these are the actual data. And so these have meshes. They have, this is the topography, so it has an image on it, and just some data. And the different ERT sections have resistivity data on them. So yeah, this is actually the data that is uploaded to View. And then what Rowan was saying was these slides. So this kind of lets you tell a story. So you can sort of position this however you think is interesting and move around, and then you can add a slide. I guess I'm not actually going to do that on this one because this is a public one, but I can do it. I can do it over here. So you can add a slide here, and then that lets you give it a title. So you can say like looking at block model. You can draw on it a bit, and you can write some notes. So you can say like, oh, this is green, and then you can save that. So in addition to having your data online as just like an online viewer, you can also sort of put together what you want to say about your data and make a bit of a presentation that anyone with an internet connection can come in and see. Yeah, I don't know. Is that good, Rowan? What else is there to say here before jumping into actually?
Yeah, I don't know. You can do some sort of interactions with the scene and like slice it and measure different bits and pieces. Also, like when you create these slides, you can create a bit of a conversation around them in terms of like giving feedback on there, which is just sort of a comment thread.
Yeah, so I mean, I guess like in principle, this could even be sort of a way to interact with an advisor or colleagues or whatever without actually having a meeting. Kind of nice.
Having a meeting. Nice.
In a perfect world.
Yeah. And then you can just sort of press the share plus button to actually get that out to more people. And put people's emails in there.
So Rowan, what is the sort of the scope of openness about this tool? Like, do I need to make it the data public to use it, or what are the scope?
So at this stage, no, not at all. We'll probably be bringing in some sort of commercial model, but hopefully we'll have something for academic sort of incentives in the same sort of way that GitHub has been run. So all of the data that you put in here is defaulted to private, and only when you share explicitly with someone does it actually go public.
Right. And let's say, like, I got a SimPEG mesh and model, for instance. What does the process look like to upload it to here? I think that's... Before you got like some sort of API for Steno 3D. Is that basically same, or?
I think that's the next part of Franklin's going to talk about.
Yeah. Yeah, so I can dive into that if you want. I don't know, just a little bit on the permissions. Yeah, so the API is open, and you actually you can't yet make one of these actually public. You still have to explicitly share with people you want to share with. Yeah, anyway, so there is a Python client now that you can pip install. So this is just pip install LFU API client. And there's docs online, lfu.readthedocs.io. And yeah, and it's a bit similar. It's a bit of an evolution from Steno, but if you've used Steno, you can probably figure it out pretty easily. So I'll jump into like the object types here. So yeah, the different element types we support. If you can see this still, there's point sets, line sets, surfaces, surface grids, and volume grids. And these all can have data on them. You scroll down here. Like on the line set segments and vertices, just like Rowan showed. You can now specify defaults, which is default visualization options. That's something you couldn't do from the previous Steno client. You just had to kind of deal with whatever it looked like when you got it up online. And then you can also add data sets to it, and you can add any number of data. We have just like numeric data and category data. And also textures. So this is just like projecting an image onto a surface. And yeah, I guess I can, I don't know, is it useful for me to just kind of like demo the Python client?
Lindsay's giving you a thumbs up.
Thumbs up, cool. I didn't plug in my second screen, so I'm flying blind. But yeah, after you pip install LFU API client, you can, oh, shoosh, I'm not paying attention from, why is this such a silly demo? Cool. So yeah, you can create a session and you can get an API key. So everyone who has the first thing you have to do is sign up for lfu.com. But then once you do that, everyone can generate an API key. Generate API key. And this is what you use to actually hit the API. So you can just copy that into Python and create a new session. And that within that token, it knows who you are and where where you're uploading data to. So that's really all you need to do to create a session. And then once you have your session, you can build your data. Oh goodness, resources, import. So we have files. This is like arrays and images. Spatial gets you elements and data and textures, and manifests. So that's like when you're actually uploading everything together, you have to put it into something called a view, and that's what you can actually visualize and grant permissions to see different stuff. Yeah, so you, let's see. I'm not sure how to dive into this. Maybe I'll actually start somewhere that's good for people who already use Steno, because that's really easy to demo here. So we also have some conversion functions. So if you have a project from Steno, then let's just get an example from Steno 3D.examples, import that one. So you can create a view from there. You can say convert Steno to view. So this is just getting an old Steno 3D project. So people probably already have scripts to generate these if you've used Steno before, and you can just call Steno to view, and that gives you a view. So this is the thing that you can actually look at in the browser, and within that you have your elements. And so that in this particular view, there's only one line set element. And then from there, you can look and see there's a couple data sets on it. Cool. And then you can just upload your view through your session. You can also, of course, create all of these things programmatically. So you can actually explicitly create an array with your vertices and your segments, and then put those into an element. Create your own data sets, add them to the elements, create your view. I don't know. Cool. Sorry, I feel like this is not a particularly clean demo, but that's okay. And then this is now the project that or the view that we just uploaded. And this is showing it in the API, but you can go to the HTML representation of it. And this now opens up the LFView app with whatever you just uploaded. Cool. Yeah, so I mean, I don't know, where is it? What's useful for me to show? What do people care about?
I think that was actually enough, because I mean, like, we just wanted to where we can find that.
Yeah.
How do we do that? I think there's an archive. So
yeah,
I mean, we can definitely start from there and then make whatever plots that we want, I guess.
Are you guys planning on being able to embed those HTMLs?
Yeah, absolutely. That's actually something we're working on today. Yeah, so the idea here is that, like Franklin was saying, you can't currently share these publicly, but we do want to be able to bring that in so that you can sort of share it in your own website or on, I don't know, social media or something. That's something that like Paul Woman and Alistair and Franklin have done on their geophysical data sets that have come along previously. So I think it's like pretty cool to get these data sets out into a wider public eye.
Yeah, and even for our examples on SimPEG, right? If we all our outputs of inversions, we should have them embedded in 3D. It would be way better.
Yeah, I think that would just be totally cool. And I think there was I forget what sort of geologic modeling product out there, but some sort of open source Python one was doing that before with Steno 3D. So hopefully we can transition them over to this as well.
I think that was GemPy.
GemPy, that's right. Thanks.
Cool.
Any other questions?
Yeah, no, that's great. And like, I never ended up using Steno 3D at the end, but I was really thinking about that. And like now that it comes up again in the it feels like it's Steno 3D like in another format. Or like, what's your take on that? The difference between the two? Is your idea to decommission Steno 3D in the future, or yeah, what's the?
Yeah, so we'll eventually migrate people off of Steno 3D. This has like a lot more longevity in sort of behind the scenes. So we'll be maintaining the LFU side and eventually sort of transition people over that are currently using Steno.
Yeah. And all the features of, or LFU is a superset of all the features in Steno.
Yeah. And it looks a lot nicer, and the performance is way better.
Nice.
Yeah.
Oh, good job.
Yes, sir.
Very cool. Any other questions? No? Well, thanks, Ron and Franklin. This is really, it's super exciting to see. And I'm excited about the OMF stuff as well, to see like what we can do to interoperate and like have SimPEG meshes actually be able to be sent to any of the visualization software. Like that's huge for everyone, I think.
Yeah, and I mean, I think that like we will be fairly early supporters of this. So even if OMF isn't exceptionally meaningful to you, I think like having the same kind of meshes in discretize get into OMF, then that means that they'll get into LFU pretty soon, which makes it an even more powerful visualization thing for this stuff specifically.
Sagi, did you have a comment?
Nope.
Okay. Cool. Are there any other last comments before we wrap things up here?
Good on our side.
All right. Sounds good. Well, we can be in touch on Slack. There's a few pull requests. I see people are pushing hard. And so we can coordinate on those and perhaps bring things together for the next release of SimPEG. Discretized docs are in reasonable shape, that pull request. But I think to the comment we made on the website, it would be nice to actually move the website to like something like GitHub Pages, so that more people can contribute to that. So there's an issue on the website repo, so feel free to chime in there if you have thoughts about how to structure the SimPEG website, because that'll impact the docs as well. Cool.
I should also mention from the LFU client side of things, I'm on the SimPEG Slack, and I'm sort of actively working on making this client library better. So if you do want to use it and want help or start using it and run into problems, then just like let me know. That's kind of another selfish reason for sharing this, is like just getting people using it and improving things from there.
Excellent. Yeah. Cool. Okay. Well, if there are no other comments or thoughts, we can wrap things up here and regroup again next week.
Sounds good.
Good.
Bye.
Thanks, everyone.
Thanks.
Thanks, guys.
Bye-bye.
Bye.